Hi, everybody. This is a video over 8.6 using your 100 integration table, the sheet. So make sure you have your 100 integration sheet out because we're going to be looking at this throughout this video. The first page basically just says it's Appendix B in your book. If you look at the 100 integration, it does say B, Appendix B. Let's take a look what's next. So let's just take here, they're just showing you a couple of formulas here. Look at formula 4 on your integration sheet. It's just showing you that, hey, the U's, if you have this integration, it forms to this. So the U's are usually where we have the variables, the X's, B is a constant in front, and then A is the constant by itself. If you start with this integration, you just find A, B, and U and plug it in. That's it. Formula 19, just a quick sheet and look at formula 19. They're just showing you once again another formula, and they're showing you that you can verify these formulas if you want. They're showing you the formula 4 can be verified using partial fractions. Formula 19 can be verified using integration by parts. Formula 84 can be used by verifying substitution. So, I mean, we can do all of those, but this video is all about using this sheet. So that's all it is. So once we get into the homework, you have to be able to figure out which formula it closely it matches. And hopefully this gives you a couple of clues on what you're supposed to be doing. Here is some intervals from and their classification. Just take a look at the different intervals that we could have. You see inverse trig functions, log forms. These are all in our formula sheet. Once again, it's just listing things that are on our 100 integration table or formula sheet, whatever you want to call it. So let's look at this. Okay, so if we look at this integration and we look through our formula sheet, we need to find something that this matches. So it's going to take some practice, and pretty much every time you find a formula that you use, I would put a check mark next to the number on your 100 integration sheet, so you know after doing the homework which ones you normally use, because we'll probably use those more often. So if we look at this, the X values, we can always change to U. So this is a U, this is a U, and then we could call this an A on the bottom. So U equals X and A equals 1. And so if we can find this, and I'm looking at my formula sheet, and look at number of formula 17. And in this one, it's kind of interesting because it says is A is greater than 0, choose the top one if A is less than 0. In other words, if A is positive, we're using the top one. If A is negative, we're going to use the bottom one, the bottom formula that they give us. And if we look at that formula 17, usually the number next to the X, if you look in here, there's an invisible 1. We call that B. So B equals 1. Now, look at our formula sheet. There's a positive in front of the B and the X. It's a positive 1. But there's a negative in front of this 1 with the A. And if you look at the formula, A is just by itself. So A is a negative 1 in this case. Okay, so I think we're all set up. If we write down the formula, this should equal 2 over the square root of negative A, arctangent, square root of A plus BU over negative A plus C. And in this case, A is a negative. So if you look at 17, I thought A was a positive at first, but if you look at the formula, A is a negative. So we're using the bottom formula, and we're just going to plug everything in. 2 over negative, then A is negative 1. Arctangent, negative 1 plus B, which is 1, U is X, all over negative 1, A is negative, oh, sorry. There's a negative there, and then we put the A, negative 1. Then plus C. So this becomes positive, so I end up with 2 square root of 1. Square root of 1 is just 1, so we end up with 2 arctangent. This becomes a positive 1 also. And I'm going to put it in the, yeah, it is in the form of the formula. A plus B plus C, and there's the answer. Two arctangent square root of negative 1 plus X plus C. All right. And let's see what they end up with. I think they end up with the same thing I did. Yes, they did. Let me go back up. And if we look down here at the bottom, we ended up with the same thing. So the formula sheet is really good. You just have to classify the letters A, B, C, or A and B and U. You have to indicate what each is and then plug it in. Reduction formulas. So what happens sometimes when you use these formulas, if you look at some of the formulas, and this is just a generic formula, but what happens is sometimes you get the integral, but then they create another integral that you have to then solve again. It's called a reduction formula. It makes it gives you a part of the answer and then makes you integrate again. And hopefully it reduces it. It's called a reduction formula to where this integral is a little easier. You may have to use a formula for this again, and then it will give you a function and maybe the answer, or it might give you another function. You know, it might give you another function to do. So it's not always just one integration. Sometimes there's two integrations, and then sometimes it creates another one where there's three integrations. I really don't think I've seen any more than three integrations required. But I mean, you could possibly have more and more and more. So let's see what else they have. So here's one, x3 sine x. So x3 sine x, integrating this, they give us some clues here. And these are the clues. They said, hey, take a look at formula 52, 54, and 55. If you look at 52, 54, and 55, we have a sine u, and all of these have a sine u. Well, this one doesn't, so we're not going to use that one at first. But then, once again, since this is u to the third. So we're going to start off with formula 54. In this problem, we're going to start off with formula 54. And if you notice here, u equals x, then the du equals 1. And that's pretty much it. I mean, the formulas all just have u's in them. So this would be u to the third. And what we're going to do is we're going to put a 3 here. We're going to put a 3 here. 3 minus 1, we're going to end up putting a 2 here. And work this out from here. And I think they show this, so let's keep on going with the slides. Sure enough, if you look at formula 54, break out your formula sheet. And the formula says negative u to the n. Oh, by the way, we already said u is x. And then in this case, n equals 3. So negative u to the n. So this is n. Cosine of then u, or cosine x, plus the n. This is n also. And then we're integrating u with n minus 1. So n minus 1 is 3 minus 1, which is 2. And we're at this point. So we just used 54 and we got this answer, but now we have to integrate this right here. And if we go back, now it's x to the n cosine. So if I go back one, if they ever let me go back, we're doing x to the n cosine, this one here, x to the n, and n is 2 this time. 2 minus 1 will be 1 here, and we're going to put a 2 here. We're going to put a 2 here. And we're going to, this is formula 55. So for that last integration part, we're going to use formula 55. So I just wanted to show that. So from here, this part here, use formula 55. All this stays the same. And if we look at formula 55, u equals x and n equals 2, go to 55 on your formula sheet, and it says u to the n, x to the n is 2, sine u, sine of x, minus n is 2, integrating u, which is x, to the u minus 1. U minus 1, 2 minus 1 is 1. So there's an invisible 1 there, sine u or sine x. So we just did for this change to this. And there's one more thing we have to do now. Look, there's still another integration that we have to do. Everything else is going to stay there to stay here, but we have to do this integration now. X sine X. So let's go back up to our formula sheet, or the ones they told us to use. And if you look, X sine X just changes to this. And that's formula 52. So I would mark 52, 54, and 55 because we'll probably be using those in the homework, on tests, on quizzes. So what we did here, we're just doing that integration. And we're using formula 52. And in formula 52, there's no n's, it's just u. I'm gonna write it down here. And it's this becomes sine x minus x cosine u. X, and then the plus C. Okay, now they don't show you, but they ended up with this, but that's okay because it's 3 times a -2 in front. So we have to multiply all this by -6. So when we do this, we get -6 sine x. Negative times a negative is a positive 6x cosine x. So all of this stays the same. The 3 also goes here. And then we end up with 6x cosine x, which is right here, and -6 sine x, which is right here, and then the plus c. So you see, we have to keep on going until there are no integration symbols anymore. And it took us 3 formulas to get to it. I haven't seen in the homework or in on tests or anything where we're going to do more than 3. I'm going to say usually it's 2, but I mean, there's a possibility of doing one like this 3 also. So all we're doing is using this formula sheet, and it's going to take it being right next to you. And every time you use one, you should be marking it off. I used 52. I used 54. I used 55. It's so the ones that you use will, a little mark will lead you to it a little quicker. Just a small mark will lead you to that formula a little quicker. It shows you that, oh yeah, you've used that formula already. Okay, so here's a problem. It says example 6, integration table. Well, if I go to my integration table, I don't see anything that works here. Sometimes you will go to your integration table where I see a sine on top and a cosine on the bottom. See if you can find anything on your integration sheet that matches that. I'm looking, and I don't see it. If you notice, the ones that say sine u and cosine u start on formula 46 and go through 57. So on your formula sheet, look at the top of formula 46. It says forms involving sine u and cosine u. Then on top of 59, it says forms involving tangent u, cotangent u. Then go to on top of problem 26 on your formula sheet. It says forms involving the square root of u squared plus or minus a squared. So and then on top of 23. So they're set up to certain categories. So you're not randomly searching. Each little grouping has its own, own area of looking at it. On top of formula 92, it says hyperbolic function. So there you know there's hyperbolic function. So on this one, let's just see what they have. Since I can't find the sine of 2x, I have to change that to something using my trig identities, my trig formula sheet. And sure enough, the sine of 2x can be changed to 2 sine, and they show that here. The sine of 2x can be changed to 2 sine x cosine x if you look at your trig formula sheet. Sine of 2x, sine of 2 theta equals 2 sine theta cosine theta. So that's on our formula sheet, and they just brought, the 2 was here, they just brought it out front. So now if you look, we can call this, since it's on the bottom and it has an x, we can call this u. U equals cosine x. The derivative of u is negative sine x. All right, so now that we have u and du, I can say, okay, if I rewrite this part, let me just rewrite this. I end up with 2 plus u. And then there's also cosine x on top. So there's a u on top. And then there's a du. So since the du needs a negative sine x, I put a negative here and a negative here. So this is what I'm looking for. This is what I'm looking for on a formula sheet somewhere. And if I look on my formula sheet, look at formula 3. By the way, a equals 2, the constant equals 2, so we're calling that a. And sure enough, oh, and we have a b. B equals 1, the number in front of u down on the bottom, there's a 1, so that's b. So this is what we have, and we're using formula 3. We have a negative 2 in front, and then the integration. Formula 3 says this is what we should have. Change it to 1 over b squared times bu minus a natural log of a plus bu plus c. So all we're doing is plugging the b, the a, and the u into the formula. B is 1, so 1 over 1 squared, which is 1. 1 times u is just u. A is 2. Natural log. Oh, and we can change the u's to x's if we need to. Yes, we do need to. Then A is 2. B is 1, 1x, then u is x, plus c. 1 over 1 is just 1. So we end up with negative 2 x minus 2 natural log of 2 plus x plus c And I'm happy with that. They might want you to distribute that. If they do, it would be negative 2x plus 4 natural log of 2 plus x plus c. And that's what I get. Let's see what the book gets. I'm sure they do this. I think they do this. Let's see. Okay, there's a formula, formula 3. A is 2, B is 1. And then they just plug it all in. I hope that's what I got. But you notice they just plugged everything in. That's du, that's u, that's u. B is the number in front here. B is 1, and this is A. And then we plug it all into the formula. All right. And last thing on this slide, is other substitutions you can use for sine and cosine. This might not be bad to write down. It says sine x over 1 plus cosine x also equals tangent x over 2. Cosine x. For integrals involving rational functions of sine and cosine, they give you some other helpful hints. All right, let's take a look at some of the homework problems now. Let me get to the homework. Okay, so problem 1 in the homework. We're gonna say u equals 8x, so the derivative of u equals 8 dx. So we need an 8 next to the dx. And in order to put an 8 there, I need to put a 1/8 here. So I'm looking for a formula that has cosine u to a power, and to a power n, and it just so happens n equals 4. Our power equals 4. So if you look at formula 51, and our cosine n u du changes to cosine n minus 1 u sine u over n plus n minus 1 over n integrating cosine n minus 2 u du. So all we're doing is plugging in u and n into the formula. N equals 4 minus 1, so we have cosine 3. U, once again, is 8x. Sine u, which is 8x. Over n is 4. Plus n minus 1, which is 3, and over n is 4, integrating cosine of n minus 2. So 4 minus 2 is 2. U is 8x. And du is 8 dx. You can see that over there on the sign. And so it should, look something like this. Don't forget, we had the 1/8 in front. So if you put all this, put a 1/8 in front of it, it should match this line here, and it does. All right, so now we have to integrate this. And if you look at, then they give you, by the way, they give you a clue here. These clues are nice, but don't rely on the clues too much. These clues are nice, but don't rely on those clues too much. I want you to look them up first and see if you can find it, and then look at it. So if you look at formula 49, 49 is cosine 2u du. And so cosine 2u du. And once again, u is 8x and du is just 8 in this case. And n equals, well, there's no n. If you look at 49, there's no n, we just have a square. So it's just part of the square. And this formula then changes to 1/2 u plus sine u cosine u plus c, and u is 8x, sine of 8x cosine 8x plus c. All right, so we need to figure out if we're going to get anything close to that. We're going to first distribute the 1/8, and we have a 4 down here. So 1/8 times 1/4 there. We end up with the 132. Cosine 8x to the third, sine 8x. So we got all this. Now we're going to do this 3/4, and we still have to distribute the 1/8. 3/4 times 1/8 is 3/32. So this becomes 3/32 because we distribute the 1/8 there. But then, so 3/32 times 1/2 in front is 3/64. So that's how we got this 3/64. And then we had the 8x, the sine x, cosine x, cosine 8x, sine 8x, cosine 8x, and then the plus c. So, I mean, it's a messy work. If I had more room, I would have rewritten all this down here, but we're using this as the answer and showing you that we did get everything that they asked for using formula 51 and 49. Okay. Let's try number 2. So we have a number here. Usually the number constant by itself is a, and then the b is the number next to the x. So a is 7, b is 1. And we're looking for some kind of a formula here. Maybe I should put it over here. A is 7, b equals 1. And we're looking for some kind of formula. Now they give us a clue, but look at it, it's x squared divided by 7 over x. And it's formula 6. If you look at formula 6, integrating u to the second power over a plus bu. And then this, it gets, I mean, there's a lot going on there. 1 over b3 minus bu over 2, 2a minus bu, plus a squared natural log of a plus bu. And then plus c. So we know a is 7, b is 1, and u is x. So b is 1, so this just ends up being 1 over 1. If b is 1, we end up with this minus 1 times u, and u is x over 2. 2 times a. 2 times a is 7, b is 1, x is u, plus a once again is 7 squared, natural log of a, which is 7, plus bu, b is 1, and u is x. So 1 times this, you don't have to distribute the 1. I end up with a negative x over 2, 14 minus x, plus 49, 7 squared, natural log of 7 plus x plus c. And it should be the same. So you see on these homeworks, it's just looking for a particular formula on your 100 integration sheet. And they call it table or appendix B in the book. They call it appendix B. They show 3 is formula 84. Let's see if we can find anything interesting here. Formula 3. So this is a good one to start us off in showing. There's in our formulas, we don't have a square root with a fraction like this anywhere. So we're going to break this. What they do is they break this apart. 6 minus x over square root of 6 plus x. Where you have a radical, you can break them apart like we just did. And then they multiply the bottom by its conjugate. The conjugate is the same thing with opposite signs. So I'm going to multiply the bottom by the square root of 6 minus x and square root of 6 minus x. Well, we're not necessarily use the table to find the integral table, use C for constant. And they're saying 41, but if you look at 41, and it's kind of important to see that 41 has the square root, but we need an a square and a b square, a square and a u square. So we have to multiply by its conjugate to get those two square roots together and multiply. to get a square like that, you have to multiply by the same thing on the bottom with the sign. And what happens to the top is nice because you can squeeze those two together on top. And it's just 6. When you multiply 2 square roots, it's 6 minus x times 6 minus x. And what you end up with is a square root of 6 minus x squared, which just equals 6 minus x on top. Now the bottom, when you multiply those two together, you end up with, on the bottom, 36 minus x squared. The middle terms cancel out, a minus 6x and a plus 6x. So this is what you end up with, 36 minus x squared. So a equals 6. Do you see this is a squared minus u squared on the bottom? A squared minus u squared. And on top, it's a minus u. So we're looking for something. Oh, damn it. I can't bring that back either, can I? Damn it. What I had was, what did I have? I had 6 minus x on top, and then I had this on the bottom. And we said a equals 6 and u equals x. This is a and this is u. So we end up with a minus u over the square root of a squared minus u squared. So this is what we have. And if we go to our formula sheet and look for that square root of a squared u squared, and if you look right above formula, once again, if you look right above formula 37, it says forms involving the square root of a squared minus u squared. Right above the formula 37 tells you, oh, this is the area for a squared minus u squared in a square root. And ours, kind of matches 41, but not perfectly. So what we have to do is we're integrating this, and let's put the numbers there. 6 minus x over the square root of a squared minus u squared. This becomes, we're going to integrate it twice because of this minus sign here. So we're integrating 6 over the square root of 36 minus x squared minus integrating x over 36 minus x squared. And I can bring the 6 in front. 1 over 36 minus x squared. So here is where a equals 6 and u equals x. And we can actually follow 41 now. And 41 ends up becoming arc sine of u over a. U is x and a is 6. So that's what that part becomes. And we just have to integrate the other part now. Okay, and so now we have to do, oh, there's a square root here. There we go, yes. Now we have to integrate this. And this is just a standard integration where we say u equals 36 minus x squared. So the derivative of u is negative 2x. So, I mean, I can rewrite this integration as x square root, or let me write it differently in exponential form. 36 minus x squared to the negative 1/2. Okay, so this is u, this is du. So du, I need to put, this is du, so I need to put a negative 2 here. And so in front, I need to put a negative 1/2. Now I have du here. And we add 1. And negative 1/2 plus 1 equals a positive 1/2. So when you integrate that, you're left with a positive 1/2, which is, 36 minus x squared to a positive 1/2. And then we have and when we put the positive, 1/2, remember you add 1, then you put the new power down below 1 and flip up the 2. So we have this is still sitting in front, negative and a negative 1/2. So these cancel, the negative changes to a positive. So our answer ends up being arc sine x over 6 to a plus this right here, which is 1/2 there. It's just the square root of 36 minus x squared plus c. And that's what we end up with. So in this one, we use rule 41. But this one just was a standard integration where we put u down here. This was all u, and this would be du, and you just integrate. We were integrating the square root of, we weren't integrating the square root of u, we were integrating this du. And so you add 1, you put the 1/2, and then you ended up with u to the 1/2. That's how we got that. Okay, let's see if there's anything else exciting here. This is not too bad of an integration here, kind of really easy. Call that u. U equals x to the 7, so du equals 7x6. Put a 7 here, 1/7. And you can go ahead and integrate that. Integrate e to the x to the 7, right? Integrating e to the x is just e to the x. Alrighty. I'm looking for one of those that have a, oh, they didn't have a double integration here. I was looking for a double integration. Why didn't I put one of those in the homework? I don't see it. Maybe I'll have some kind of a supplement to do 1 or 2 of those. Hopefully we have one of those on the quiz. All right, so that's it. That's now I labeled the PowerPoint was labeled 8.6, but the homework is 8.7. It's really the same thing. I think it used to be called 8.6, but with the new edition of the book, they changed that section to 8.7. So I'll go in and change the PowerPoint. The PowerPoint should label itself as 8.7. And the homework is 8.7, but it's the integration using the tables. So whether we call it 8.6 or 8.7, it's still integration using the tables. And the only homework assignment that we have in there between 8.6 and 8.7 is 8.7. The only thing that's really messed up was the PowerPoint, because I had the PowerPoint labeled 8.6. But in reality, the PowerPoint should be labeled 8.7. Everything else is 8.7. I hope this video helped. Let me know if you need anything.